I do so.
Okay, so I said that first the query's syntax gets checked, wherein it checks whether the all the keywords in the statement are correct or not. Okay, the syntactical checks needs to be done. Oracle does that. The next thing that it has to check is the semantics of the query. Now, what exactly is the semantics? Internally, when the user wants to check all the details of employees who report to this specific manager, okay, he has fired this query, but the database also, or Oracle also, has to verify whether this user who wants to see all this data has the accessibility rights to check the data of the EMP table or not. Okay, because there may be n number of users in the database, but not everyone is supposed to have access to each and every table. Okay, so there may be some user who just wants to try their luck and wants to look at some critical tables, who is actually which are actually supposed to cater to the requirements of the management. Okay, so if a query has been fired in the database, Oracle also needs to verify whether the user has the accessibility rights on that specific tables or not. Okay, those things are part of the semantics check of the query. Okay, so what we mentioned until now was that the query's SQL ID will need to be generated. Okay, then the query's syntax will have to be checked. The query's semantics has to be checked. Okay, so all these things internally it is being done by the server process. Okay, the syntax checks, semantics checks, all these things are taken care of on behalf of the user by the server process in the database. Okay, clear with this, Deepak?
Yes, yes, Dhruv.
Yeah, fine. I'll go back to my architecture window. Okay, I'll stop share for a moment. Again, I'll try to share it with the architecture window. Is it visible, the architecture window now?
Yes, it is visible.
Okay. Okay, so when that user has fired the query which we were just referring to, all those details like SQL ID has been generated. Okay, so that SQL ID and the SQL text will get stored into something called as the shared SQL area. Okay, now the question that we should ask at this moment is, why does Oracle need to store that SQL statements, SQL text and its SQL ID? Okay, so at this moment just understand that it is to enhance the reusability in the database. Okay, now why that reusability is important? Okay, now let's go back to the same example.
This one was for shared SQL area, right, Dhruv?
Yeah, shared SQL area. Yeah, we are still on shared SQL area only. Do you see this Notepad++ window now?
Yes, yes.
Yeah. Okay. So it is the same. I just opened it in Notepad++. Okay. So here, when the user has fired this specific query wherein he wants to see the details of all the employees who are reporting to the manager with ID 1, it might happen that there are other users also in the database who fire the exactly the same query. Okay, then there is another user who also fires the same query. Then there is another user who also fires the same query. Now if there are going to be multiple executions of the same query in the database. Although let's say that let's for the sake of clarity, let's consider it as a correct statement with the correct syntax. Okay. So if there are going to be multiple executions of the same query in the database, it doesn't make sense for the Oracle server to do all these things like syntax checks, semantics checks, and I mean the whole execution of the query every time the same query has been fired in the database, right? Let's say that if you are going to do some task, okay, and if someone asks, you have completed that task, you have all the details about that task now, okay. Now if someone asks you to get that task done again, okay, you are not going to completely do it once again, right? You will just make use of the previous information that you have stored with you, okay, while you did that task for the first time. Okay, so what Oracle will do, Oracle will, when the query was executed for the first time, Oracle will generate an SQL ID, it will do the syntax checks, semantics checks, okay, and it will store all those details in the shared SQL area. Okay, why it will share that, why it will say store that information in the shared SQL area? Because it doesn't want to waste its time and resources when some other users or the same user fires the same query again in the database. So to enhance the purpose of reusability, Oracle stores these information in the shared SQL area. What that, Deepak?
Yes, bro.
Okay. So along with this, Oracle also will have to generate something called as an execution plan of the query when the query was executed for the first time. Okay. Now, what exactly is an execution plan? Okay. So to understand the execution plan, let's take an example wherein if you have to travel, say, from Mumbai to Delhi, okay, you log into any of those sites where you can book the flight tickets, and you get to see a number of options. And there will be direct flights from Mumbai to Delhi. Then there will be some flights which are via, say, uh, Amritsar, some, let's say, another flight which is via going via Pune or any other place, right? Now, when you are going to choose, what exactly is going to be the deciding factor for choosing any specific flight out of the listing that you see on the website? Okay, so there are going to be two important criteria. First of all, how much time does it take? Okay, so normally the direct flight would take lesser time. Okay, and at the same time, it might also happen that the cost of that specific direct flight is lesser, or it might happen that the cost of the flights which are going via other cities, that is lesser. Okay, so those are going to be the two deciding factors, okay, for choosing the specific flight whichever you would want to fly with. Okay, so similar to that, when Oracle receives the execution request for any specific query, Oracle will have to prepare an execution plan. What exactly is an execution plan? How it is going to fetch the result set of that specific query from the database, that is called an execution plan. Internally, what all operations it will have to do, it will plan for that. Okay, that is part of the execution plan. Okay, and how Oracle chooses that specific execution plan? It internally, it will try to find, it will go through 2 or 3 execution plans. Okay, but it will choose the execution plan which is best suited in terms of what? It should be able to fetch the result set in least amount of time as compared to the other execution plans that it has access to. Okay, and it should consume least amount of resources as well to get the result set of that specific query. Okay, so those are the 2 deciding factors behind Oracle choosing a specific execution plan. Okay, let's go through it once again. Okay, to understand it in a much more clear manner. Oracle receives a request to execute this query. Okay, Oracle, now we will discuss only the shared SQL part, shared pool part of the query execution. Okay, so Oracle will have to generate an SQL ID. The syntax has to be checked, semantics has to be checked. Okay, then it will generate an execution plan. While it is generating the execution plan, internally, it actually generates 2 or 3 execution plans, but it will choose the best one from those. Okay, we generally don't get to see those 2 3 optional plans. Okay, we only get to see the details of the plan that is chosen, but internally Oracle will choose only the best execution plan out of those 2 3 that it will prepare. Okay, on what basis it chooses the execution plan? On the basis of how much time it will be taken to get the result set and how much resources will be consumed. Okay, so the one that will consume least amount of resources and the one that, or and the one which is going to take least amount of time, that will be the execution plan Oracle will choose. Okay, and it is also called as the optimal execution plan, the best suited one. Okay, so
Dhruv,
Oracle will,
is
yeah,
execution plan generated prior to the query execution, or it executes 2 to 3 times and after that it chooses from them?
no, see, that will be generated at the time of execution plan only, not after, not when the query is, I mean, actually executing, fetching the result set.
Okay, so it gets generated prior to the query execution, and from
Yep,
that
that's right.
it
In the
chooses one.
the see, the shared pool part is coming into picture before the result set comes into picture, right? All
Yes,
these things have to be done first. First, you will decide the action plan, and then you will actually start working according to it, right?
correct, Dhruv.
Yeah. So, so that execution plan is also stored inside the shared SQL area. Okay. Now again, why that needs to be stored? Just because if the same query is going to be executed again and again by different users, Oracle will be able to reuse that information. It doesn't have to spend time doing the same thing again and again. Okay, that's why Oracle is storing all that information in the shared pool. So shared pool, or say inside the shared SQL area, okay, it is a pool of all the SQL IDs, its execution plan, its SQL text, okay, for the purpose of reusability. Okay, let's go back to the architecture slide. I'll share that one now. Do you see the architecture slide now, Deepak?
Yes, Dhruv, I do see the architecture screen.
Okay, so all that information related to the SQL statement is getting stored inside the shared SQL area for the purpose of reusability. Clear with that?
Okay. Yeah. Clear.
Similar to that, we also have something called as a shared PLSQL area. Now that shared PLSQL area is going to do the same set of tasks. It has the same purpose which you see for the shared SQL area. Okay, there is a difference between SQL and PLSQL. PLSQL will be having all those programming language things that we get to see, like the loops and conditions, all that part. Okay, so whatever
Okay.
is the function of shared SQL area, similar to that, we also see shared PLSQL area. It is just that it is specific to the PLSQL. Okay. Now, the next thing that we see inside the library cache is something called as a private SQL area. But we have already seen something like a private SQL area in the PGA. Okay. So why is it being shown inside the shared pool as well? But if you see the text over here, it says shared in case of shared server only. Okay, so Oracle has given us a concept called as shared server architecture, and we also have got something called as a dedicated server architecture. What's the difference between that? In case of dedicated server architecture, that's what we discussed initially. Every user process will have a dedicated server process. Okay, that is called as a dedicated server architecture. In case of shared server architecture, there will be multiple user processes. Okay, they will be connecting to a specific set of server processes. Okay, so the server processes, the number of server processes will be very much lesser as in case of shared server architecture, and multiple user processes will basically be sharing the server processes. Okay, so if you are going to implement the shared server architecture, in that case this private SQL area will be present inside the shared pool. Okay, but in industry we don't get to see much of the shared server architecture. It is mostly the dedicated server architecture, mostly as in almost 99%. I haven't come across any scenarios in for any of the client wherein they have implemented the shared server architecture. It is by default dedicated server architecture only. Okay, so that is about the library, that is about the shared SQL area, pair SQL area inside the library cache. Okay, the next thing that we get to see inside shared pool is the data dictionary cache. Okay, what is this data dictionary cache? Internally, Oracle also needs to fire the queries internally for itself as well. Okay, now going back to the previous example wherein the query, Oracle had to do a semantics check wherein it had to find whether the user who has fired the query has the accessibility rights on those tables or not. So how did it find those details? Okay, that is one example. First, then it can be like if you want to find out on which date this specific database was created, what is the size of the database? Okay, what are the various locations wherein all these database file types are present? Okay, so if you want to fetch some information about the database itself, okay, that is metadata of the database. In technical terms we call it as metadata. Metadata is like you want to fetch some information about the database itself. Okay, so those information are basically stored into something called as data dictionary. Okay, and this data dictionary cache that you see inside shared pool, it is only a small representation of the entire data dictionary. Okay, data dictionary, like I said, it is a set of internal tables which in which the information regarding the database is stored. Say if you want to find how many users are there, on which date those users accounts are going to get logged as in till which if there is any specific date on which the password will expire, those kind of details. Okay, so all that information is stored inside the data dictionary, and this data dictionary cache is just a representation, small representation of that entire data dictionary. Okay, you got that, Deepak?
Okay. Yeah, Dhruv. Got that.
Yeah. Okay. The next component that we see inside the shared pool is something called as a result cache. Okay. Now, what is this result cache? If we go back to the previous example wherein we said that the same query is being fired by multiple users in the database, and we said that to enhance the purpose of reusability, Oracle stores the query's text, SQL ID, its execution plan, right? So that it doesn't have to generate the execution plan again. Okay. So similarly, Oracle also provides you an option to store the result set of the query, so that if the same query is fired again and again, Oracle can straight away get the result sets from the memory itself. Okay. So, sorry. So you have the option to store the result set of the queries for future reusability. Okay. Now, by default, this feature is not enabled in the database. If you want to enable it at whole database level, there will be a specific parameter that you have to enable. You have to make use of that parameter to enable that feature for the entire database, which means that each and every query that will be fired in the database, you want to store the result set of all of those queries. Okay. Otherwise, if you want the results to be stored for specific SQL statements, then you have to make use of something called as SQL hints. You have to pass on certain hints when you fire the query to Oracle that I want the result set of this query to be specifically stored in the result cache. Okay, because you are pretty much sure that this query is going to be fired again and again, and I don't want Oracle server to waste its time in getting the result set for again and again. Okay, so that is the purpose of the result cache. Important thing to remember is it is not enabled by default. It is never enabled at database level. Okay, I haven't come across any specific client wherein it has been enabled at the whole database level. Okay, Oracle has given us that feature, but it is not much used. Okay, so that is about the result cache.
So,
Clear, Deepak?
yeah, but can a user manually store the results in a result cache, as you are saying now?
So that's where the SQL hints come into picture. If he has provided the SQL hint in the query to store it has asked Oracle to store the result set. Okay, in that case, that specific query's result will be stored.
Okay.
The user has to provide that specific hint. Okay. Another thing to remember about this result cache is that if you make any changes in the structure of that table, okay, you add a column, you delete a column, mm, to any of the table that were present in the query. Okay, the result set of that query will again be purged out. It will be invalidated. Getting it?
Yeah, got it.
Okay. Yeah. Now, one more thing that we should understand while we are discussing this important component called library cache is that It is not going to be possible to store the SQL ID and execution plan for all the queries in the database forever. Okay, you are not going to have an infinite amount of memory for the shared pool, so that you can say your database was created 4 years ago. Okay, it is not going to be possible to store the SQL IDs that have been fired in the last 4 years. Okay, you will be allocating a specific amount of memory to the shared pool. Okay, maybe in few GBs, like say 10 GB, 12 GB, something like that. Okay, but that 10 GB or 12 GB is not going to be enough to store the SQL IDs of a highly transactional database, wherein thousands of queries will be fired on a daily basis. Okay, so in that case, Oracle makes use of something called as an LRU algorithm. Okay, it makes use of an algorithm called as LRU, which stands for least recently used. Now, what that least recently used algorithm is, if let's say that you allocated 500 MB of memory to shared pool, let's say that it is a very small sized shared pool and you have allocated only 500 MB. Okay, at some point that 500 MB will be full. Okay, and now one of the user has fired an SQL statement, and that SQL statement has been fired for the first time. So Oracle needs to store the all those details in shared SQL area for that SQL statement, but there is no space left. So what it does, internally it will have to purge one SQL statement which has not been used until recently. Okay, so it will purge out automatically one or two statements from the shared pool which has not been used for a long time, which has been present in the shared pool or say inside the shared SQL area for a longer time. Okay, so that's how Oracle maintains the space inside the shared pool. It has to automatically take care of it has to ensure that it preserves the statements which are being fired again and again over the statements which are not being fired again and again. Okay, which are the users are not trying to execute those statements again and again, so those statements can be purged out. Now Oracle will do that automatically by itself. We don't have any control over it. Okay, generally we don't have any control over it, but there are some ways wherein by hook or by crook, if you want to say Oracle that I don't want this to be purged out of the shared pool, that is also possible. We won't get into that at this moment, but understand that Oracle has to maintain the space inside the shared pool by using the LRU algorithm. Okay, got that, Deepak?
Yeah, Dhruv, got it.
Okay. Okay, we will stop here for the day and then we'll continue again. Okay, Deepak?